When solving an inequality, if you multiply or divide by a negative number, you change the direction or sense of the inequality. And I'll show you why in a minute. So sense is the direction. So greater than would turn into less than. Greater than or equal to would turn into less than or equal to. So you want to use an open dot when you're graphing the inequality if it's less than or greater than, and you want to use a closed dot if it's less than or equal to or greater than or equal to. So an open dot would look like this on a number line. So this would be x is greater than 0. And a closed dot would look like this. Closed dot, shade to the right, x is greater than or equal to 0. Okay, so a closed dot means it includes the endpoint, and open dot, it means it doesn't. So why do we change the direction? So if you multiply each of these numbers by -1, see how they're all in order? -5 is less than -4 is less than -3. If we go through and multiply all these by -1, so I'll do that here quickly. So I'm changing them all to opposites. It's no longer true that 5 is less than 4, so you'd have to actually change the sense of the inequality. So that's what you need to do when you multiply or divide by a negative number. Okay, it has to be multiplying or dividing by a negative, not have a negative in it. So we'll do some examples. So example 1, solve and graph. So in this case, what I would do is I would get rid of fractions. So I have a 3, a 4, and a 12. So in order to clear fractions, I'm going to multiply everything through by the least common multiple of 3, 4, and 12. So 3, 4, and 12 can all go into 12. So when I do this, I'm going to multiply 12 times 2, which is 24, and then dividing by 3. So a fraction is just multiplying and dividing. So this would be 24 divided by 3, which is 8x. Then I multiply 12 times 1, which is 12, and divide it by 4. So that's going to be -3. And then 12 times 5 divided by 12, 60 divided by 12 is 5. So solving for x, oops, I dropped my inequality symbol here. So solving for x will give, it's not erasing for some reason, 8x is greater than 8, so x is greater than 1. So to graph it, I'm going to put an open dot. So I'll mark this 0, open dot at 1, and numbers that are greater than 1 that would satisfy this are going to the right. So 2 is greater than 1, so 2 is going to the right-hand side. Okay, second example. So I'm going to use the distributive property here. So -2x plus 8 minus 8x less than or equal to -20. So this is going to be -10x plus 8 less than or equal to -20. I'm going to subtract 8 from both sides. So -10x less than or equal to -28. And then divide by -10. So I'm dividing by a negative. So because I'm dividing by a negative, not because this number is a negative, I need to switch the sense of the inequality. So it's going to turn into x is greater than or equal to 2.8. So I put a 0 right here, 1, 2, 3, and then 2.8 right here. And this is going to be a closed dot because it's a greater than or equal to. It's equal to. And I'm going to shade to the right because these numbers are greater than or equal to 2.8. Okay, next one. So this is another situation where I can clear fractions. So I want to think of a number that 5, 2, 12, and 5 all go into. So all of these numbers, so what I do is I think of multiples of 12. So 12. I can't divide 12 by 5 and 2. 24. I can't divide 24 by both 5 and 2. 36, no. 48, no, not divisible by 5, and then 60. So 60 is divisible by 12, 5, and 2. So I'm going to multiply all of these, both sides, by 60. So the faster way to multiply fractions is to do 60 divided by 5 first, then multiply it by 1. You're not going to get a different answer if you multiply 60 times 1 and divide it by 5, but it's faster. So I'm going to do 60 divided by 5, which is 12. 12 times 1 is x. 60 divided by 12 is 5. 5 times 5 is 25. 60 divided by 2 is 30. And 60 divided by 5 is 12. 12 times negative 6 is negative 72. So now that I have this expression, or this inequality, I'm going to get x's on both sides, or to one side. So add 72x, add 72x. This cancels out, so I have negative 30 is less than or equal to 25 plus 84x. So I subtract 25, so negative 55 is less than or equal to 84x, and then divide both sides by 84. So I have negative 55/84 is less than or equal to x. And I can rewrite that as x is greater than or equal to negative 55/84. Okay, because each side, x is greater here and x is greater here. So if you think about like a Pac-Man, Pac-Man is biting x in each of them. So those are equivalent. So negative 55/4, I'm going to put 0 on the number line. It's going to be left of 0, so negative 55/4 is 84, is a little over halfway. It's going to be a closed dot, and I'm going to shade this way. So it's negative 55/84. Okay, fourth example, I'm going to do the distributive property. So negative 2x minus 12 minus 8x less than or equal to negative 20x plus 5. So negative 2x and negative 8x is negative 10x minus 12 less than or equal to negative 20x plus 5. Add 20x to each side. So 10x less than 12, or minus 12 less than or equal to 5. Add 12, 10x less than or equal to 17. And then that gives me x is less than or equal to 17/10, or about 1.7. So if this is 0, this is 1, this is 2, this is 1.7, so this is between 1 and 2. So I make a closed dot, and it's less than or equal to, so it's going to the left. Now you can have special situations of inequalities too. So two situations are no solution or all real number solution. So no solution would mean no matter what you plug in for x, you're not going to ever get a true statement. And all real numbers means that you can put in any number for x and it's going to be true. So just the same thing can happen with equations as inequalities. So this would be 3x. 3 times 1/6 is 3/6, and that's 1/2. So this is 3x minus 1/2, and this is 3x minus 1/2. So getting our x's on one side, these x's would cancel out. And also, these would cancel out. So you'd have nothing on each side, so it'd actually be a 0. So then you want to look at your statement at the end. Is 0 less than or equal to 0? Is that a true statement? It is a true statement. So if it's a true statement, that means the solution is going to be all real numbers. That means that you can plug in any number in for x, and the left-hand side is going to be less than the right-hand side. So if it's true, it's all real numbers, and then we'll check this one here. So I have negative 7x plus 12 greater than negative 7x plus 20. So I'm going to add 7x to each side. So I have 12 is greater than 20. So 12 is not greater than 20. This is a false statement, so if the statement is false, the solution is going to be no solution. So no matter what you plug in for x, you're not going to get a true statement. So there's no number for x, no real number that you could plug in and have it work.